Okay. Good afternoon, students. Today we'll do a new lecture, new topic that is on hypothesis testing. So it is very important topic. So you nowadays you are free at your home, so better to do these kind of things and that too promptly because it's very important to learn about hypothesis testing. So we start with the hypothesis testing. We have done have read enough times, a lot of times about hypothesis in the class. So it is about hypothesis testing from unit 3. Hypothesis testing, it is a sort of inferential statistics and a very important tool used by a business researcher to arrive at a meaningful conclusion. So, as we know, there are two types of statistics. One is descriptive, and second one is inferential. Descriptive statistic is to describe, or to describe about something, or it is an addition to an existing knowledge. But here we are talking about inferential statistics, that is to arrive at some inference or some meaningful conclusion. So that is why hypothesis testing is used. So in management, decision makers need answers to certain questions in order to take optimum decisions. If we take example, suppose it is actually used in every aspect of management, either it's in financial management or in marketing or in any other field. So for example, vice president of a company wants to know the effectiveness of training program which company organize for all its 170 employees based at 130 locations in the country. So, right. So, here we are talking about what the vice president of the company wants to know how effective the training program is. So, in order to find answer to this question, decision maker need to collect the sample data, right? So, the sample data is collected from the whole population. Then, researcher will compute the sample statistic and then further use this information to find the correctness of hypothesized population parameter. So, agar in layman language, we can say that decision maker have to hypothesize first, then apply the test statistic. So, getting back to the above example, where vice president of the company wants to know the effectiveness of training program. So, vice president takes a sample size of 629 from all locations in the country. The VP will then set an assumption that training has not enhanced efficiency. So, this is our hypothesis that training has not enhanced efficiency, and we'll accept or reject this assumption through a well defined statistical procedure, which is actually known as hypothesis testing. So, what do you mean by hypothesis testing now? It is a well defined procedure which helps to decide objectively whether to accept or reject the hypothesis based on the information available from the sample. Now come to the second thing. So now come to the hypothesis testing procedure. So there are basically 7 steps in hypothesis testing. We start from the first step. The very first step is set null and alternative hypothesis. We have already done a lot of things in the class, a lot discussed lot of times about null and alternative hypothesis. So null hypothesis is generally referred by H naught, which is tested for possible rejection under the assumption that is true. So we are here setting the null hypothesis that there is a no difference between population means. So we know it is generally referred by H naught. So H naught would be mu is equal to mu 0. Mu is equal to population mean. Mu naught is equal to hypothesized value of population mean. So I'll try to explain it through example. For example, to test whether population mean is equal to 0, a null hype is equal to 0, or sorry, it's not 0, it's 150. So to test whether the population mean is equal to 150, a null hypothesis set as mu is equal to 150, and we know alternate hypothesis referred by HI. So when a null hypothesis found to be false, that mu is not equal to 0. So the alternate hypothesis must be true or vice versa. Therefore, we'll write alternate hypothesis as mu is not equal to mu 0. That is, the population mean is not equal to hypothesized mean. And we have hypothesized, that is 150 as a hypothesized mean. So it might be greater or it might be lesser than the population mean. So you can look at, that is mu is greater than mu 0, and the h1, third h1 is mu is less than mu 0. It means your population mean is less than the hypothesized mean. So we have three conditions, that is mu is not equal to mu 0, one is greater than, and the third one is lesser than. Alternate hypothesis can be set as population mean is not equal to 0. As you can easily check here, H1 is of three types, where it is first is it is not equal to 150, it is greater than 150, and third one is it is lesser than 150. So this is about the first step, that is about setting null and alternative hypothesis. Now come to the second one. So step 2 is of determine the appropriate statistical test. So we had already decided about the hypothesis. So now come to about the decision on appropriate statistical test. It depends on what type of data you are using. Are you using nominal, ordinal, categorical data, interval data, or ratio data? Number and the level of data may provide a platform for this. So through these kind of things, that the categorical data, interval data, ratio data, we can decide upon the statistical test. Now mean, proportion, variance is also considered to apply the statistical test. So it is necessary to check these kind of things to determine appropriate statistical test. So here comes step 3, that is set the level of significance. So we already have done 2 steps. The very first step was, that is about the setting of null and alternative hypothesis. The second step was determine the appropriate statistical test. Now come to the third step, set the level of significance. What do you mean by level of significance here? Level of significance generally denoted by alpha, which is attached to null hypothesis, which may be rejected even when this is true. So it is also known as size of rejection region or size of critical region. Hey, you can see a picture, you can see a figure that is of the normal curve. So on both left and right sides there are rejection regions, and on both the sides there are acceptance regions. So the z value of left hand side is minus 1.96, and at the right side it's plus 1.96. So from where we have taken these values? That is from the normal distribution table we have taken the z values. So you can also check one value, that is 0.475 on both sides, right? And on above of it is written 1 minus 0.5 is equal to 0.95. So here we are taking 0.95, means 95% of confidence interval. We are confident that our data is 95% normally distributed, and the rest 5% is not. So our acceptance and rejection region, this is at the 0.05 level of significance, or we can say it's 5% level, 5% level of significance. So the next one is, that is the same thing, similar, but it is at 1% region or 0.01 alpha, that is 99% confident interval. So you can see both the normal distribution curves. The first one is of 95% confidence interval, and the second one is at 99%. If you go to the first again, so here there are two numbers, 0.4750 on both sides in the acceptance region. If we if you add both of it, 0.4750 plus 0.4750, it actually comes to be 0.95, that is 95% distribution. So H no in one into this is two. One more thing. These are the two tail tests, because rejection region are at the both ends of the normal distribution curve. So for these are known as two tail tests. So how can we set the hypothesis for it? So H naught would be mu is equal to mu 0, and H1, that is alternate, is mu is not equal to mu 0. So you can have a look here, acceptance and rejection region, that is at alpha 0.05, and second one is 0.01. So this means a researcher will reject the null hypothesis, the hypothesis, and if the computed sample statistic is higher than or lower than the hypothesis population parameter, considering both the tails right as well as left, then we will reject the null hypothesis. It should not be higher or lower than the hypothesis population mean. Now come to the one tail test of hypothesis. So you can see here, only on the right hand side or the left hand side is a rejection region in the one normal distribution curve. If you go ahead, it is a one tail test, and that is the left one. And here you can see z is equal to 1.645, and in the center mu is equal to mu 0. It means population mean is equal to hypothesized mean. And you can check here 0.50 acceptance, and here it's 0.45, because rest 0.05 is level of significance and your rejection region. Similarly, it's a right tail test, and it is also one tail, right? You can have a look, and both are at the 0.05 level of significance. Now your fourth step, not fourth step yet, it's hypothesis setting for one tail test. So how you can set the hypothesis for one tail? So you will start here. H node mu is equal to mu 0, and H1 is mu is less than mu 0. That is up for the left tail test. Similarly, mu is greater than mu 0 for right tail test. And the null hypothesis is same for in both the cases. For example, as per the previous example, the null hypothesis is equal to 150. A two-tailed hypothesis can be, that is, mu is not equal to 150 in case of two-tailed hypothesis. It might be greater than 150, or it might be lesser than 150. Similarly, if we go for one tail, we have only chosen one option. Either it's for the left tail, and either it's for the right tail. Now, step 4 would be the set the decision rule. The next step is to establish a critical region. What do you mean by critical region? I already told you that is the critical region. It is the if the computed value falls in the acceptance or region, or null hypothesis is accepted, otherwise it is rejected. So it is the area under the normal curve divided into two mutually exclusive region, that is acceptance and rejection, as already explained in detail. Step 5 is about collection of sample data. So I want to put forth one point here, that you have to collect the data after completing above given four step. Firstly, you have to check your population mean is greater or less than whatever the value of hypothesized mean. Step 6 is analyze the data. Researcher has to compute test statistic, so it involves selection of an appropriate probability distribution for a test. For example, when sample is small, suppose your n is less than 30, the use of normal distribution, I mean to say z test, is not good choice. T test needs to be used. The very last step is arrive at statistical conclusion and business implication. It is the last step. It actually a decision making step to accept or reject null hypothesis. Further decisions are made on the basis of this information and needs to be implemented for meeting the organization goal. I hope I have cleared your concept. You got you get all the clarity on hypothesis testing. If you have any doubt, kindly contact me. after circulation of this video. Thank you.